go on to this second part B of this chapter, carboxylic acids. Let's just take a introduction. Now when we're talking of carboxylic acids, they are the organic compounds which contain COOH group. Okay? Now the name of this group, that is known as carboxyl group, and that is going to be derived from two words. As you can see over here, we have carbo and we have oxyl. So the word carbo, that is derived from the carbonyl group which is present. Right, you can see that C double bond O that is going to be present over here. So carbo, that is derived from carbonyl, and oxyl, that is going to be derived from hydroxyl. So this is the hydroxyl group which is present, and this is going to be the double bond O, the carbonyl group which is present. But it is very surprising that it does not have the properties either of the carbonyl group or the hydroxyl group. The carboxyl group has its own distinctive properties, right? It is going to have its own distinctive properties. The acidic character, which is the most important property and the most common property of the carboxylic group, the acidic character, that is due to the H positive or the hydrogen ion which is present in the carboxyl group. So more easily this H that is going to be released, more is going to be the acidic character, which we will study in the coming section. Now when we are talking of classification of the carboxylic acids, they are classified into monobasic acids. Monobasic acids are those carboxylic acids which are able to displace only one hydrogen atom, and we have over here monocarboxylic acids with CH3COOH. Okay, so monocarboxylic acid means which is going to have only one carboxyl group. So you can see over here that it has only one carboxyl group, COOH. Such acids, they are known as monocarboxylic or monobasic acids, which can only release one hydrogen atom. The second type of acids we have, they are dibasic acids. So dibasic acids, they are going to displace two hydrogens. They are the dibasic acids. So when we are talking of dibasic acids over here, we can take an example of a dicarboxylic acid having two carboxyl group. An example which we can take over here is that of oxalic acid. Okay? Now oxalic acid is going to be a dicarboxylic acid. And then we have a tricarboxylic acid which is going to have three COOH groups. And these acids, they are said to be tribasic in nature. For example, we have CH2COOH, we have CHCOOH, and we have CH2COH. So as you can see that there are three carboxylic groups which are present over here. Such acids, they are said to be tribasic or they are said to be tricarboxylic acids. Now monocarboxylic acids specifically, when we are talking of, they are known as monocarboxylic acids. They are said to be derived from fats. Therefore they are known as, more commonly known as, fatty acids. Generally the fatty acids, they have a larger number of carbon atoms which are attached to the monocarboxylic group. For example, we have C15H31 COOH, which is known as palmitic acid. Okay? C15H31 COOH, which is known as palmitic acid, or we have C17H35 COOH, which has even more number of carbon atoms, and this is known as stearic acid. So as they are obtained from fats, So they are known as palmitic acid or they are known as fatty acids, and the fatty acids they generally have a large number of carbon atoms which are going to be present. ठीक है? फिर उसके बाद we have saturated monocarboxylic acids also. They may be all these, they are said to be saturated monocarboxylic acids. They all have the general formula of the type CN H2N plus 1 COOH. This is going to be the general formula of all the monocarboxylic acids, or it can also be put as CnH2nO2, right? So this, it can have either a general formula of this, or you can also put the general formula in the form of CnH2nO2. So this is what the general formula of all the monocarboxylic acids is going to be. Now saturated monocarboxylic acids, they are also said to be derived from paraffins. What are paraffins? They are alkanes. So when one of the hydrogen in alkanes that is substituted by a hydrogen by a COOH group, that is going to give us the acid. For example, if we have CH4 minus H plus COOH, this is going to give us CH3COOH. So you can see that it is derived from paraffins, right? So saturated monocarboxylic acid, they are also considered to be derived from the paraffins. In a similar manner, monocarboxylic acids, they can also be obtained from the oxidation of the CH3 group. Okay, so first of all, what we said, that they are derivatives from which we get from the fats, therefore they are known as fatty acids. Second, we are saying that they may be derived from paraffins by the substitution of one of the hydrogen from COOH group. Thirdly, we are saying that they may be derived by the oxidation of the CH3 group. Oxidation of the CH3 group. ठीक है? जैसे for example, if we have CH3 and we've taken a molecule of ethane over here, when we are doing the oxidation of this, all the three hydrogens, they are going to be oxidized. So we have OH group, 3OH group attached to the same carbon atom. Now this is a very unstable compound. It will immediately lose a water molecule such that we have CH3C OH and double bond O. So this is how the carboxylic acid that may be obtained. Now this basically the idea of this oxidation of the CH3 group that came from the formation of the formic acid, because the formation of formic acid could not be explained from either paraffins, or we could not say that they are derived from the fats. So therefore, when we are taking a molecule of methane over here, the oxidation of methane, that is going to oxidize all the H over here in a similar manner as we have done above. So यहाँ पे हमारे पास क्या आ जाएगा? We have OH and OH, right? Now this is going to lose a water molecule such that we have HC, OH and double bond O, right? So this is how formic acid that is obtained. Now monocarboxylic acids, they can also be regarded as derivatives of carbonic acid. So this is the fourth method which we are going to discuss over here. We say that monocarboxylic acids, they are regarded as derivatives of carbonic acid. Right? So if we have over here C double bond O, OH and OH, right? Now this is going to lose lose one hydroxyl group and an alkyl group is going to substitute that OH group over here. One of the OH that is going to be substituted in carbonic acid by R. So what are we going to get over here? We will get COH R double bond O, which is going to be the carboxylic acid. Okay, so what is this carbonic acid over here? It is going to be H2CO3. That is what the carbonic acid is. So this is how you can say the carboxylic acids, they can be derived. And the monocarboxylic acids, when we are talking of specifically monocarboxylic acids, they are also known as monoprotic acids. Okay? They are going to be also known as monoprotic acids. So let's go on to the nomenclature. There are going to be three methods by which we can name the carboxylic acid. The first one, that is the common or the triple system of nomenclature. In case of common system of nomenclature, it is seen that the name is generally given according to the source of the carboxylic acid. Like for example, if we are taking HCOOH, this HCOOH that is derived from red ant, right, formica, from the stink of the red ant formica, that is how it gets the name formic acid. Then we have over here CH3COOH, right? This is obtained from vinegar. Vinegar has the name acetum, so that is how we get the name over here as acetic acid. Okay? फिर उसके बाद we have like C3H7COOH. C3H7COOH. This is derived from or obtained from butter. So that is how it has the name butyric acid. Okay, so these are certain common names which we have over here depending upon the source from which we are going to get the particular acid. The second system of nomenclature that is known as the derived system of nomenclature. Now, in case of derived system, monocarboxylic acids, they are taken as alkyl derivatives of acetic acid. Okay? जैसे for example we have CH3, CH2COOH. Now this is going to be known as CH2COOH is the acetic acid. With that a methyl group is attached. So this is going to be known as methyl acetic acid. Okay? Similarly, if we have a compound or an acid like this is known as dimethyl acetic acid, as there are two methyl groups which are present. So this is going to be known as dimethyl acetic acid. So according to the derived system, this is how we are going to name the compounds. Okay? फिर उसके बाद we have another system which is the most important one which we are going to do over here, that is the IUPAC system of nomenclature. According to the IUPAC system of nomenclature, the acids, they are going to be named as alkanoic acid. right? Which means we have alkane minus E plus oic acid. Okay, so this is alkane minus E plus oic acid, alkanoic acid, right? Let's take an example. We have HCOOH, alkane which is present over here is going to be methane. This is the first member of the series. So, methanoic acid, methanoic acid, right? In a similar manner, if we are taking the second member of the series, CH3, CH2, COOH, this is going to be, this is the third member of the series. There are 3 carbon atoms present. Remember that in this case you also have to consider the carbon atom of the carboxyl group which is present over here. So this is going to be 1, 2, 3. This is known as propanoic acid. Okay? So over here, this functional group that is known as the terminal functional group. Now if we have a longer chain of the type, then in that case you want to follow all the rules of nomenclature. We have CH, CH, CH3, CH3, CH2, COOH. So over here this carbon atom that is always going to get number 1. Even if it is violating the other rules. Okay? So you have number 1, 2, 3, 4 and 5. So we have 3, 4 dimethyl pentanoic acid. So this is how you can name them, right? Then next we go on to the isomerism in carboxylic acids. Let's go on to the isomerism. In case of isomerism, the first type of isomerism which we have, that is chain isomerism. Now by chain isomerism, the chain that is going to be different and the molecular formula that is going to be same. So we have CH3, CH2, CH2, COOH, right? This is known as butanoic acid, right? Now the chain, if the chain is different, the compound will now become okay, this is going to be known as 2-methyl propanoic acid, right? Then the next second type of isomerism which it can exhibit, that is functional isomerism. In this case, you will see that when we are talking of monocarboxylic acid, it shows many number of functional isomers, like they are functional isomers with esters, they are going to be functional isomers with hydroxycarbonyl compounds, they are going to be functional isomers with hydroxyoxidanes. So if we are taking one compound with the molecular formula C2H4O2, okay? The acid which we are going to have over here is the second member of the series, which is acetic acid. Okay, now इसका जो functional isomer होगा, that can be this. You can see that the molecular formula of both that is going to be same. This is known as methyl formate. Okay? In a similar manner, this can also have a functional isomer of the type CH2OH and CHO. This is known as glycoaldehyde. This is known as glycoaldehyde, or we have hydroxyethylene, which has the formula so all of these, they are going to be functional isomers of the compound C2H4O2. This is known as hydroxyethylene oxide. ठीक है, फिर let's go on to another compound C3H6O2, which has the formula CH3CH2COOH, which is going to be propanoic acid. Now the isomer of this can be this is known as 2,3-epoxy-propane-1-ol. This is how you're going to number the carbon atoms. So it is 2, 3, with the second and the third there's an epoxy group present. Okay? So this is 2, 3-epoxy-propane-1-ol. This is how you name it. Or this can have methyl acetate as one of the functional group, or one of the functional isomerism, CH3COOCH3, methyl acetate. Then it can also have a functional isomer of this type. This is going to be ethyl formate. Okay, ethyl formate. So these are some of the you can say functional isomers of C3H6O2. Now over here functional isomers के लिए बात कर रहे हैं rest of the compounds in which we've done alcohols, we did ethers. Then they did not have so many functional isomers as the carboxylic acids have. They have the maximum number of functional isomers which can be formed from one particular compound. ठीक है? Then we go on to optical isomers. All those carboxylic acids which are going to have at least one chiral carbon atom, they are going to be monocarboxylic, or they are going to show optical isomerism. So we are taking over here 2-methyl butanoic acid. This is 2-methyl we have to take. This is 2-methyl butanoic acid. So if you're looking at this carbon atom over here, this carbon atom is the chiral center, because all the 4 groups attached to it, they are going to be different. So this is 2-methyl butanoic acid, or it is also known as optically active valeric acid. Optically active valeric acid. ठीक है? Clear हो गया? So this is a general introduction of carboxylic acids which we've done. Let's go on to methods of preparation of carboxylic acids. We are going to general methods of preparation of carboxylic acids. The first one we have already discussed in aldehydes and ketones, that is oxidation of alcohols aldehydes and ketones, right? Now when we're doing the oxidation, the oxidizing agents which we can use over here, the first one which we are going to use is K2Cr2O7, potassium dichromate in sulfuric acid, or we can use KMnO4 in alkaline or acidic medium. Right? Or we can use Jones reagent, which is chromium trioxide in H2SO4. This is going to be the Jones reagent. So we can use either. We can use potassium dichromate, we can use potassium permanganate, or we can use chromium dioxide in H2SO4. Now over here, when we're talking of oxidation from alcohols, we've already studied that when we're doing the oxidation of alcohols, the first compound which we are going to get over here is an aldehyde, which is going to further get oxidized to RCOOH. Okay? Or if we are having over here, let's take an example. We are taking CH3CH2OH, which is ethyl alcohol, in presence of any of the oxidizing agents. This is going to first give us CH3CHO, and oxidation of this is going to give us the respective acid, which is ethanoic acid. Right? Now when we're doing the oxidation with Kr2O7 and Jones reagent, it is seen that there is always a small amount of ester also which may be formed with the acid. So in that case, what we can do is that in order to remove the ester from the respective acid, then distillation can be done and both they can be separated. Okay? So there's very little amount of ester as impurity which may be formed over here. When we're talking of aldehydes, we've already seen that the aldehydes, they may be oxidized by mild oxidizing agents as कौन से करे थे हमने टोलेंस, ठीक है. Then we did Fehling solution. Then we did Fehling के बाद what did we do? Bentic solution. So all these mild oxidizing agents, they are going to you can say oxidize the aldehydes to ketones. Now when we are talking of unsaturated alcohols, for unsaturated alcohols, as for example we have CH, if this is the compound which we have and we need to form an acid without affecting the double and the triple bond over here, we use chromium trioxide in H2SO4 in acetone. Okay? So the product, you will see in the product there is going to be no effect on the double and the triple bond. Okay? Then we have over here secondary alcohols. The secondary alcohols also, they can be selectively oxidized to acids, to ketones. Secondary alcohols, they cannot be converted to acids. यहाँ पे गलत करा है, यहाँ पे आएगा आपका COOH. Same ही compound लेते हैं हमने, ठीक है? COOH. So if we are talking of secondary alcohols, so secondary alcohols जो है, they are not going to be converted into acids. They are converted into ketones rather than acids. Most preferably, it is only the primary alcohols which may be converted into the respective acids. ठीक है? Clear हो गया? So secondary जो है, they are going to be oxidized to ketones, और फिर उसके बाद हम ketones की further oxidation करेंगे, तो हमने पढ़ा है कि Popoff's rule के according we are going to get mixture of acids, right? So ketones, they can be oxidized further to give us mixture of acids. For example, if we have CH3CO, CH2, CH2, CH3. In this case, if oxidation of this is done, you know that the keto group that will remain with the smaller group over here. So the mixture of acids which we have, that is CH3COOH plus CH3CH2COOH. This is what we are going to get over here. ठीक है? Clear हो गया? So this is how you can form the acids. Now acids may also be formed from one reaction which we have already done in our previous lesson, haloform reaction, in which the iodoform that is going to be formed. So this reaction, that is a peculiar reaction of only the methyl ketones, if you remember. It's a test for the methyl ketones. Now over here we are going to react this with sodium hypohalite, we can react it, or we can react it with a halogen in presence of NaOH, okay? And in the second, we react it with water. So what are we going to get over here? We will get the respective acid. And we will get haloform. So this reaction also we have already done when we were doing the test for methyl ketones, right? Then we go on to the second method of preparation. These are all the oxidation reactions which we've done over here. The second method is hydrolysis of alkyl cyanides. Hydrolysis of alkyl cyanides. Now in this case, alkyl cyanides, they have this bond, functional group C triple bond N. Now in case we are adding water to it, you know that over here the lone pair of electrons, they will shift towards nitrogen because of high electronegativity of nitrogen. So nitrogen, that is going to have a slightly negative charge, and carbon, that is going to have a slight positive charge. Okay? So over here, when this is going to be formed, then from here the negative part will go and attack at the carbon atom, and the positive part is going to attack at the nitrogen atom, such that we have an addition product which may be formed in either acidic or alkaline medium. So what is going to be that addition product which we have over here? We have RCOH double bond NH. Now this addition product, that is known as unstable imidol. Okay, फिर इसकी rearrangement होती है. This hydrogen that is going to go over here, and it is going to give us a respective amide, NH2. This is going to be the amide, and then we do the acidic hydrolysis of this. ठीक है? So we get the respective acid. Clear हो गया? What is going to be the mechanism? Let's take an example over here. We have CH3, CH2, C triple bond N. This is known as propane nitrile plus HOH. Same mechanism. OH will attack at the carbon, and hydrogen that will attack at the nitrogen. So we're going to have an unstable imidol, CH3, CH2, COH, double bond NH. Okay? Now, after that, rearrangement of this is going to take place to give us the respective amide. So we have CH3, CH2, C double bond O, and NH2. Right? And the hydrolysis of this, that is going to give us an acid, CH3, CH2, C double bond O, and OH. Okay, so this is what the reaction that is going to be. Now, while we are doing the preparation of carboxylic acids by this particular reaction, you need to know certain points. aldehydes. Like for example, the hydrolysis that can be done in presence of an alkali also. In presence of an alkali, we are going to get the sodium salt. Okay? Secondly, alkyl halides, they can also be used. So this is going to be an upgradation reaction for the conversion reaction. So let's see what is upgradation reaction over here. We've seen that the cyanides which are required for the reaction, these cyanides which are required for the reaction, these cyanides, they are generally formed from alkyl halides. So if you're taking CH3Br, reacting it with KCN, this is going to give us CH3Cn. And then the hydrolysis of this in presence of an acid, that is going to give us CH3COOH plus NH3. Okay? So this is an upgradation reaction. Why? Because in the reaction there is only one carbon atom which is present, and when we are going to the products there are two carbon atoms which are going to be present. So whenever you need to form higher fatty acids than the lower ones, then you can use this formula. And when we are preparing formic acid, HCl that should be used instead of RCl. So the hydrolysis of HCl in presence of an acid, that is going to give us formic acid, right? So for the preparation of formic acid, rather than using an alkyl nitrile, we should use HCl. Clear ho gaya? Then we go on to the third method of preparation, hydrolysis of terminal trihalogen derivatives of alkanes. Hydrolysis of terminal trihalogen derivatives of alkanes. Okay, so in this case what we are going to do, we are taking a trihalogen derivative, all the X which is going to be present over here, we've already done this reaction, and we react this with sodium hydroxide. When all the X they get substituted by the OH group, so we have RC, OH, OH and OH. Now this is going to be highly unstable as it will lose a water molecule. So this is going to lose a water molecule to give us the respective acid, which is RC double bond O and OH. Okay? So this is how we can get it from the trihalogen derivatives of alkanes. If we have any other compound, let's take an example. We are taking 1,1,1 trifluoroethane, reacting it with 3KOH. All the three chlorides they will get substituted. Right? And this is going to lose one water molecule over here to give us the respective acid. Okay? So this is how the acids they can be formed by hydrolysis of terminal trihalogen derivatives. Right? So today we will do only till here. We have certain other methods of preparations which we will discuss in our next class. Alright?